Okay, in part 2, we have equation that have a random variable that has a gamma distribution. To obtain a moment generating function of a gamma distribution, we have the formula of a moment generating function is mxt equal to expected of exponent of xt. As the equation given is continuous distribution, so we use integration to find a moment generating function. The formula is integration of 0 until infinity exponent of xt fx with respect to x. So we integrate with respect to x. Now we substitute the fx. The fx is beta to the power of alpha x to the power of alpha minus 1 exponent to the power of negative beta x over gamma. Next, we take out the beta to the power of alpha over gamma and we let s equal to beta minus t. Beta minus t we noted here is greater than 0. Now we substitute beta minus t and we replace it as s. Next, we divide beta to the power of alpha over s to the power of alpha and we multiply s to the power of alpha here over gamma. And we know integration of 0 until infinity exponent negative x alpha minus x is gamma equation, that equation given here. So it's become 1. So next, we take out the power of alpha out of the equation and we let beta minus t over beta to the power of negative alpha. And lastly, we have 1 minus t over beta to the power of negative alpha, which
Hi
noted
and
here is t
Assalamualaikum
less than beta.
warahmatullahi wabarakatuh. My name is Nur Fazira Natasha Binti Murad and today I will explain to you guys part 2 question number 2. Next, find the expected value and variance for this random variable using the moment generating function. To find the expected value, we must differentiate the moment generating function with first derivative. So here, after I differentiate, I got alpha over beta, open bracket, 1 minus t over beta, close bracket, power of negative alpha minus 1. And then to get the value of expected value, we must substitute the value of t with 0. And then after I substitute the value of t with 0, the final result for the expected value is alpha over beta. Then, to find the variance, we must find the expected value power of 2 first. To find it, we must do differentiate again, which is do second derivative for at the moment generating function. So here, the second derivative, I got alpha multiplied with alpha plus 1 over beta power of 2 multiplied by 1 minus t over beta power of negative alpha minus 2. To get the value expected value power of 2, we must substitute t with the 0. So, the final result for the expected value power of 2 is alpha multiplied by alpha plus 1 over beta power of 2. And then, to get the variance, we substitute into the formula of the variance, which is expected value power of 2 minus with expected value power of 2. So, after we substitute the value that we already got, the final answer for the variance is alpha over beta power of 2.
So for part 3, I will explain about the moment generating function, focusing on discrete for two random variables. So for easy understanding, we have a specific example of discrete function on how to obtain a moment generating functions for two random variables. The example has the joint probability functions for x and y, which for variable x, it has three possible outcomes, 1, 2, and 3. And for variable y, it has two possible outcomes, 0 and 1. To obtain the moment generating function for the discrete random variables, the moment generating function is defined by the expected value of e to the t1x plus t2y is equal to the sum over all variable of x and y, e to the power of t1x plus t2y times fxy. Next, we need to substitute the given fxy from the joint probability functions for x and y. The MGF for x and y is equal to the sum of x equal to 1 until 3 and the sum of y equal to 0 until 1 e to the power of t1x plus t2y times fxy. After substituting the fxy into the formula, the MGF of x and y will equal to 0.2 e to the power of t1 plus 0.3 e to the power of t1 plus t2 plus 0.1 e to the power of 2 times t1 plus 0.2 e to the power of 2t1 plus t2 plus 0.1 e to the power of 3t1 plus 0.1 e to the power of 3t1 plus t2. So that is how to obtain the moment generating function for discrete random variables.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nirana Natasha Pitron Saharudin and I will present for part 3 for continuous. So I pick the function which is e negative x minus 2y for the limit x 0 until infinity and for y 0 until infinity. So for continuous random variable, the moment generating function defined as the given formula, which is we should do the double integral and we multiply e t1x plus t2y with the given function. So for this question, we multiply e t1x plus t2y with e negative x minus 2y. So before we integrate, we should factorize the x and y so it will be easier for us to integrate. So we will get e negative x in a bracket 1 minus t1, e negative y in a bracket 2 minus t2. So and then we integrate for y first and then we will get negative e negative x in a bracket 1 minus t1 over 2 minus t2. Okay, after we integrate, we should substitute the limit for y, which is infinity and 0. So, after we substitute the infinity and 0, we will get e negative x in a bracket 1 minus t1 over 2 minus t2. And then we should integrate for x. And then we get negative e negative x in a bracket 1 minus t1 over in a bracket 1 minus t1 2 minus t2, and then we should substitute the value of x, which is infinity and 0, and then we will get 1 over 1 minus t1 2 minus t2, and that is the moment generating function for e negative x negative 2y. That's all from me. Thank you.
Assalamualaikum and hi everyone. My name is Nur Ain Atika binti Zulkifli and I will explain the last question in part 3, which is how to find the covariance value for this random variable using the moment generating function for discrete and continuous distribution. For discrete, we get the answer just now in part 3 question number 1, which is mxy t1 t2. After that, we have to substitute t2 equal to 0 into this equation and we get this equation. After that, we have to differentiate respect to t1. To get the mean value of x, we have to substitute t1 equal to 0 into this equation and we get 0.2 plus 0.3 plus 0.2 plus 0.4 plus 0.3 plus 0.3 equal to 1.7. Next, we have to substitute t1 equal to 0 and we get this new equation. And next step, we have to differentiate respect to T2. To obtain the mean value of y, we have to substitute T2 equal to 0 into this equation. And we get 0.3 plus 0.2 plus 0.1 equal to 0.6. After we obtain the mean value of x and the mean value of y, we have to find the mean value of xy. How to find the mean value of xy? First, we have to differentiate respect to t1 and differentiate second times respect to t2. After that, we can substitute t1 equal to 0 and t2 equal to 0. And we get 0.3 plus 0.4 plus 0.3 equal to 1. Next, we can find the covariance value using this formula, which is mean value of xy minus mean value of x times mean value of y. Next, we substitute the value that we obtained just now, which is 1 minus 1.7 times 0.6 equal to negative 0.2. Next, we can find the covariance value for continuous distribution. We get the moment derivative function in the continuous distribution just now, and we substitute t2 equals to 0 into this equation. We get the new equation. After that, we can differentiate respect to t1. To find the mean value of x, we substitute t1 equal to 0 into this equation, and we obtain the mean value of x equal to 1. After that, we substitute t1 equal to 0, and we obtain this equation. After that, we can differentiate respect to t2, and to find the mean value of y, we can substitute t2 equal to 0 into this equation, and we get 0.25. After we obtain the mean value of x and mean value of y, we have to find the mean value of xy. First, we have to differentiate respect to t1 and differentiate second times respect to t2, and we substitute t1 equal to 0 and t2 equal to 0 into this equation. We get this equal to 0.25. After that, we can get the covariance value, and we substitute into this formula and get 0.25 minus 1 times 0.25 and equal to 0. That's all from me. Thank you.